JSCPAO, this is Houston. Please call station for a voice check.
Station, this is JSCPAO. How do you hear me?
Hello, we hear you loud and clear.
Awesome. Okay, so first we're going to go out to the social media followers who are at the Kennedy Space Center in Florida for the launch of NASA's Radiation Belt Storm Probes mission. KSC, over to you.
Hi, Joe. This is Rans Adams at KSC, Twitter handle @MedicRans. I was wondering, how do you cope with being away from your family for such a long period of time? Long-duration ISS crew members have said how isolating it could be aboard the station. What keeps you going and what keeps your spirits up?
Well, don't tell my family, but, I don't feel too isolated up here. We're talking to Mission Control all day long. They get to see us, and we have a lot of communication there. But with my family, we speak every week on a video conference, so we see each other often. Also have the telephone, so I can call if I have to. We have email. So NASA's done a lot to keep us in communication with family and friends. So it's really not too bad at all. I was a Peace Corps volunteer, and I lived somewhere without electricity, and I felt a lot more isolated there than I do now. And looking out the window is motivation to stay up here and just enjoy it.
This is Dave Higgins, @DaveHiggins1, Twitter handle. This question's for Suni. Are night launches visible from the ISS? And will the ISS be in a position to look for the Friday launch of the Radiation Belt Storms probe?
Well, launches are visible, but you have to be at the right place at the right time because, we're going pretty fast to 17,500 miles an hour or so, and so we zip past places pretty quickly. We actually tried to look when Progress was launching out of Baikonur, and we saw the launch platform, but we didn't get to see a launch. Not exactly sure where we're going to be on Friday at that particular time, but if we're anywhere near Florida at night, we'll be keeping our eyes open because nighttime viewing from this space station, from the cupola, is just incredible, and you can really make out all sorts of cities and areas. So I'm sure if there's xenon lights lighting up the launch pad at the Cape, and we're anywhere nearby, we'll be able to see it.
Buenas tardes, Joe. Pedro Vázquez de Kennedy Space Center, @Delicious Blur on Twitter. Joe, ¿qué clase de platos preparaba su mamá para usted cuando era un niño? Y estoy curioso si ha obtenido algún plato similar en la órbita. Adelante, Boricua.
Well, muchísimas gracias. Por supuesto, la comida favorita es la comida puertorriqueña, arroz con pollo, el pollo guisado con tostones. Y en la Navidad los pasteles, pero también mi mamá cocinó la comida americana y mexicana, pero sí, yo quiero regresar y comer esa comida otra vez. Y aquí tenemos como un pollo que se llama pollo fiesta, chicken fiesta, y es delicioso con una tortilla.
Hi, this is Evie Marone, Space Girl Evie with a U. My question is for Suni, and I would like to know how much radiation does the ISS crew receive during an average 6-month period mission compared to that same amount of time on Earth? And what kind of protection do you have in the event of a solar storm or flare?
I don't know all the exact numbers, but a fact that's thrown out there is it's about like 10 times the amount that we get on Earth per day. So it's a pretty high amount of radiation that we get while we're up here. However, we've got radiation covering around the space station. We wear dosimeters all the time. In fact, we have them for when we go out on spacewalks as well to see if we get any additional radiation through the spacesuit. And so it's monitored pretty well. All of the modules in the space station also have radiation monitors, and that information gets sent back down to the ground, and also our dosimeters when we come back home, and so they can get a good idea of exactly how much radiation we get. And yeah, we do get warnings if there is some type of solar activity or high radiation event. And if that's the case, then we'll go to a part of the station that's a little bit more sheltered and stuff to prevent us from getting too much radiation.
Hi, this is Rena Warren, Rena W on Twitter. This question is for Joe. There are so many NASA-developed technologies that we use in everyday life. What, if anything, is in use on Earth that came from an experiment on the ISS or technology developed for the ISS? And in the end, what do you think will be the biggest benefit to mankind from the ISS program?
Well, that's a great question. And yeah, over the years, NASA has developed all kinds of technologies that we use every day. And that continues today. Since we've been up here, Sonny just yesterday was working on a project with fire, which is always fun. And what they can get from that is we can learn the properties of fire, and they can improve the models that we use on the ground. So there's a lot that's happening, working with fluids and how they move in different types of tanks. So we're continuously improving that. And I would invite all of you to go to the NASA website, to the spin-offs section, and you can see everything that NASA has done, and I can guarantee you'll find something that you use that is a spin-off from NASA. And what we might find in the future, what's cool now is the ISS is a national lab. So what that means is that in the future, half the science we do will be proposed by scientists around the world, and the other half will be done by NASA scientists, so we can go out further past low Earth orbit. And what's cool about exploration is you don't know what you're going to find, and that's what I'm excited about. I think some cool things are going to happen here in the future.
Thank you, Joe and Sonny. Now we're going to go to social media followers who are on our phone bridge. They're calling from all over the world. So callers on the phone, will you please state your name and also where you're calling from? Let's go with number one, Laura.
This is Laura Garcia Oviedo. I'm Science Walker on Twitter, and I'm calling from San Carlos de Bariloche, Patagonia in Argentina. This question is for Suni. Why is it important that human beings, not just robots, explore space, for example, Mars? Do you live and work with many robots aboard the ISS?
Well, Laura, as a matter of fact, you could probably see Robonaut right in front of us. And today we brought him out to try him out and see how he could do for some of the simple tasks, as we're trying to actually perfect robots so that they can actually use their hands. His hands are actually like our hands. And so he's trying to do some fine, dexterous things. And then in the future, we can potentially use something like this outside to do tasks that right now we have to do. So yeah, humans have to be in space at this moment in time to do stuff like spacewalks and do some of the fine manipulation stuff if we're going to change boxes or electronics equipment outside. And speaking of exploration, think about the rovers that are on Mars. That's just incredible that Curiosity is there and doing its thing. But if it runs across something that maybe we hadn't planned, it's going to mean people back on Earth are going to have to sit down, think about all the pros and cons to make a decision. Now, if there was a human there on Mars, they could use their best judgment, engineering judgment, scientific judgment, medical judgment to make that decision pretty quick, and things could happen a lot more rapid. So I think humans are definitely needed for further of exploration and to find things that we didn't even expect. Machines usually do things that we expect. It's more the human being that's curious and to find the next thing that we need to explore.
Hi, my name is Gloria Lloyd. I'm also Gloria Lloyd on Twitter, and I'm calling from Raleigh, North Carolina. My question is for Joe. And other than your family, what is the thing that you miss most from Earth? And what are you most looking forward to when you return?
Well, I think after being here for a little more than 3 months, and I have one more to go, the one thing that I miss and I'm looking forward to is actually the climate back on Earth. We live in this fairly sterile environment, which is very comfortable if you live in Houston this time of year. But I look forward to getting back and feeling that sun on my face, sitting by the pool, working on my tan a little bit. Just feeling the sun, feeling the wind, feeling the rain. Those are things that we miss up here. And I don't know, maybe a barbecue bacon cheeseburger with a vanilla shake would be good.
Hi,
this is Lindsay Newton calling from Liverpool in England, and my question is for Sunny. I know that you've got spiders on board at the moment, but what other creatures have made it onto the ISS?
Yeah, you're absolutely right. We have 2 spiders in their habitats, and we've been watching them prey on the fruit flies. It's been pretty interesting. In the past, we've actually had some other spiders, and I think that was the first time I was able to answer a question that I got from a 5th grader about how do spiders make webs in space, and that's actually was a pretty interesting thing for us to watch real time here and earlier previously. They pretty much adapt. Other animals that we've had mice up here before, not too long ago. On the space station, I think those are all the animals we've had, but in the future, we're going to have fish. Our other crewmate, Aki Hoshide from JAXA from Japan, has been getting the aquarium ready to go, and I think on by the end of the year, we should have some fish up here to put in there and see how they work.
Hi, my name is Aiden Callahan, and I'm calling from Boston, Massachusetts. My question is for Joe. Would having a permanent low Earth orbit station be feasible, and how could we make it happen?
Yeah, I definitely think it's feasible, and you could almost look at the space station we're in now and call this a permanent structure. It's been here for the past almost 12 years, and we have agreements in place to keep it here until 2020. So we're looking at a 20-year period of having the space station. So I think we've proven that you can have a structure in low Earth orbit for a long period of time, and it may continue even longer. And what we really need to keep this one going or future stations in orbit is the support of the community. You know, this is an international space station. It's not just one country, but when you get the whole Earth working together, it's amazing what we can do. And I wouldn't be surprised if a lot more people in the future are orbiting the Earth just like we are today.
Hi, this is James Gomez at Gomez James. I'm calling from Aliso Viejo, California. Sunny, what's been the most memorable event so far of your current mission?
I think probably, you know, coming up here on a Russian spacecraft, the Soyuz, was pretty unique. Last time I flew up here was on a U.S. space shuttle, and that was just amazing. You know, first time going to space, it's just awesome, and the rocket's huge, and it makes a lot of noise. But the Soyuz is something different, and in particular, working with our international partners, our Russian partners, and understanding and learning about the history of that program, and then, you know, coming here and docking to the International Space Station, that part has been really awesome. But, you know, parallel to that was when Joe and Aki grabbed HTV and docked that to the International Space Station. And I think you're getting the gist of what I'm saying is when anything new comes, it's always exciting. We also had a Progress that came up to the space station, and it launched and got here within 1 day. So that's a brand new flight profile. So that's been, all of that dynamic stuff's been really exciting. And I'm not saying the science isn't either. It's just we sort of get all ramped up for the dynamic parts, and so that makes it just a lot of fun to wake up the next day and see what's on the plate for what's going to happen.
Hey guys, my name is Yesenia Arroyo, Twitter handle Yanasa7. I'm calling from Orlando, Florida, and this question is for Joe. How are astronauts dealing with bone loss? Have any new discoveries been made to help with that?
Yeah, bone loss and muscle atrophy is a big problem that we have being up here for a long period of time, but we've come a long way. And so for their muscles and the bone, we exercise every day for about 2 hours. Part of it is on the stationary bicycle that we have here, but we also have, see, look at that, that's how good it is. And we also have a machine called ARED, which is a resistive exercise device that feels just like a universal machine in any gym, you know, back home. And we have a treadmill that we wear a harness so we can run on that, and that impact also helps with reducing the bone loss. So with those 3 things, we've learned a lot about it. We're also taking part in an experiment where we eat special diets to see if the foods that we eat, if that can change what our bone loss is like. So we've come a long way. We have a lot to learn, and what's neat is what we learn up here, we're also going to be able to use back home. So there's a lot going on, and there's always something new to learn when you're exploring.
Next caller, Holly.
Yes, my name is Holly Smar, and I'm calling from Lockport, New York. And my question is, may you both briefly share your thoughts on what the Mars Curiosity landing means to you?
Sure, that was a pretty exciting day up here. We actually got up a little bit early because it was about 5:30 our time, GMT, to see what happened, and we were anxiously watching NASA TV through our radio links here to find out what happened. And I just think it was amazing. I think the whole public probably knows about the landing profile and how its entry profile, and it's pretty amazing. You know, brand new technology, really creative ideas. You know, a great group of people out at JPL. You know, that's what's going to take us into the future and get us out of low Earth orbit. So, to me, I think it's the next step. It was really awesome.
Yeah, and Sonny hit it right on the head. If you watched the landing, you felt that excitement that was going on at JPL. And so don't think that NASA isn't exciting and we're not doing a lot of neat things, because we are. And so that was just another milestone as part of the exploration. And so I think when you have projects like that and then eventually having astronauts go to Mars, some really neat things are going to happen.
Hi, this is Amurabi Sevilla from Villahermosa, Mexico. My question is for Joe. How is breathable oxygen generated aboard the station?
So basically the oxygen that we're generating, we have two systems, one on the U.S. side of it and the other one on the Russian segment. And they both work the same, where we're splitting water, and from that you have hydrogen and oxygen. We also have visiting vehicles that will come up and they can bring us oxygen, and so we will also take it from those tanks. And in case we had some kind of a situation where we couldn't make our own, we have a couple of devices that we can go through a chemical reaction and produce oxygen. So we're in good shape, and with the way that we can recycle water now, it's almost as if we have an endless supply that we can generate.
Hi, SUNY. My name is Andres Almeida. My Twitter name is Andres David. I'm calling from Washington, D.C. What other sorts of experiments are being conducted aboard the space station?
So, like we alluded to earlier, we're doing a whole myriad of experiments on ourselves. That's, you know, first and foremost like a biology experiments, trying to find out what happens to the human body living here in space for a long period of time. And Joe touched on bone loss, bone density, muscle loss and density, and also another experiment, cardiac, find out what is actually going on with your heart in space. You know, it's a muscle, so it absolutely, you know, probably more than likely shrinks a little bit in space, and so how is that all affecting the way we're doing stuff on ourselves? Also, we're doing reaction type testing. How does the body over time react? That might change the way we design control systems if we're in space for a long time, going like to Mars, and maybe we might have to make a control system that would be a little bit more applicable to be a changed reaction time. But other things we're doing, those are just things on ourselves, and there's more than what I'm saying. But there's also like materials type stuff, capillary flow, the burning fire experiments that I was talking about, that Joe was talking about. There's experiments that are going on outside with AMS. There's Robonaut type of experiments. So there's a ton of things. Also, like I talked about earlier, the animals that we have up here, the spiders, the fish, and tons of experiments from, like Joe said, all over the world. And so, I mean, too many even to talk about. And like Joe said, on the NASA website, there's probably a ton of them if you want to take a look and see what we're doing on a daily basis. And I'm sort of surprised. Every day I wake up and I look at our schedule, and there's something new on there that I've never done before. So it's exciting to be up here, and we appreciate all the PIs who are taking advantage of this laboratory.
Station, this is JSCPAO. Thank you very much for all the wonderful answers you guys provided. We were able to get through all of the callers, and we have run out of time. And as always, we really appreciate everything you do for us. And happy 100 days, Joe.
Thank you very much. It's gone by quickly, and thanks for joining us today. It was fun talking to you all.
The station, this is Houston ACR. That concludes the event. Thank you.